Hello students, today we will discuss about an important topic of class 12th. It is Gauss theorem. Let's start. Student, Gauss theorem is very important, and in every exam there is a question based on this statement of Gauss theorem, its derivation, its proof, or any numerical based on this theorem. So what is it? Let's start. Gauss theorem states that total electric flux through a closed surface in a vacuum enclosing a charge is 1 by epsilon naught times total charge enclosed. If we are calculating total electric flux, students, we know electric flux is the number of electric field lines crossing unit area. So how much how we will calculate total electric flux? It is surface integral of electric field and the surface area. This is our electric flux. So if we imagine a Gaussian surface, this is Gaussian surface, and at the center of which a charge q is enclosed, and radius of the surface is say r, and here we consider an area element ds, and we know electric field is always outward normal, and electric field and area element are in same direction. So we will prove now that E dot ds is equal to q by epsilon naught. Epsilon naught means q is the charge enclosed and 1 by epsilon naught is the its multiple, or this is the statement of Gauss theorem that total electric flux is 1 by epsilon naught times the charge enclosed. So now if we calculate, or if we know value of electric field at this point, which is at a distance r, is known as E is equal to q upon 4 pi epsilon naught r square. This is magnitude of E only. So if we put its value here, we know E dot ds is equal to E ds cos theta, and theta is 0 degree. So E ds. So if we put value of E and ds here, E is q by 4 pi epsilon naught r square, and ds, surface integral of ds, if we integrate all the area element present at this Gaussian surface, it is 4 pi r square. Now put these values here. So we will get E into 4 pi r square. E is equal to q upon 4 pi epsilon naught r square, and we will calculate the total flux is q by epsilon naught. This is the proof of our Gauss theorem with the help of Coulomb's law, because this relation comes from Coulomb's law. So how we apply this Gauss theorem, or what is the result, important result by which we can solve numericals. So if we wish to find electric field due to a thin infinitely long charged wire, uniformly charged wire, whose charge density is, linear charge density is lambda, then at a point r from the wire is known, electric field is lambda upon 2 pi epsilon naught r. This is the value of electric field due to a thin, uniformly long, straight, uniformly charged wire. And if we wish to calculate electric field due to a thin charged spherical shell of radius r at a distance small r from its center, then electric field is q upon 4 pi epsilon naught r square, where small r is the distance, and this relation is when r is greater than r. Or if we calculate its value, if r is less than r, then E is 0, means inside the shell. And if we consider electric field at the surface of the spherical shell, it will be q upon 4 pi epsilon naught r square. These are the some standard results. You should keep in your mind that some numericals may be based on these results. And this is about Gauss theorem, its statement and its proof, and in between the definition of electric flux. So electric flux is a scalar quantity, and it is the total number of electric field lines crossing unit area, and it is also known as surface integral of electric field and area element.